So in assignment number 7, we're going to be graphing linear inequalities. We started graphing systems of equations, and we're going to move on from equations today and move to systems of inequalities. But before we get to systems of inequalities, let's just take a look at a few graphs of inequalities. Let's start with one like this. So we remember y equals mx plus b. This is the same thing, except instead of an equal sign, we have an inequality sign. And so y-intercept is still going to be at 3. So we're going to start with a point right here at 3. And then we're going to have a slope of 2, which means that's the same thing as 2 over 1. So we're going to go up 2 over 1 for another point, up 2 over 1 for another point. I can keep doing that, or I can go down to left 1, down to left 1. And all of these points here are going to be on my graph. So this line is included in the graph, and it says all the y values that are greater than or equal to that. So all the y values that are greater than are everything on this side. And so that means that everything on this side of the line is going to make the equation true. We can pick any point out here. Let's just say I pick this point right here. This point here is -5, +3. If x is -5 and y is +3, if I plug those in, it's going to make that equation a true equation. For example, y is 3. That's greater than or equal to 2 times -5. Well, that's -10 plus 3. And -10 plus 3 is -7. So 3 is greater than or equal to -7, which means that point makes this equation a true equation. And every point here, even the ones that are decimals, that are in between everything, would make this equation a true equation. And so my solutions are an infinite number of solutions. They include everything on the line, because it could be equal to this, and everything above the line, which is where I shaded. Let's take a look at another equation. So here, same kind of equation, y equals mx plus b form. The y-intercept is at 2, so I'm going to have a point to start off with right here at 2. The slope you can see is 1/2. So I'm going to go up 1 and over 2 for my next point, up 1 and over 2 for my next point. I'm going to continue that same process, going up 1 and over 2. I could go down 1 and left 2. And the only difference is here, it's not equal to this line. You can see it's just less than. The last equation, it had like a bar underneath it, which means it's less than or equal to that line. So here it's just less than that line, which means nothing on this line is going to work. And so for that reason, I'm going to make a dotted line here, meaning that that's a boundary line, but it's not actually any solutions. Everything on that line is not going to make the equation a true equation. The only thing that will make the equation true is all the y values that are less than that. Well, the y values that are less than that are down here, which means everything below this line, everything down here, all of these points in this entire region are going to make the equation a true equation. And so it would include everything, in this region, but it wouldn't include the line itself. So first thing you might want to write down is this. If it's less than, if it's in slope-intercept form and it's less than or equal to, you're going to shade below the line, below the line. If it's greater than or equal to, you're going to shade above the line. Another thing you might want to write down is if it looks something like this, where it's less than or greater than, it is a dotted line. And if it's less than or equal to or greater than or equal to, it is a solid line. Okay, so this chart in your notes might be helpful for you as you graph these equations. So let's go on to a different type of problem. Here we have number 4 is an equation in standard form. And so we can graph this inequality in 2 different ways. First way we could do it is to put it back in the equation in the form that we like, which is slope-intercept form, which means we're going to get the y by itself. So to do that, we're going to subtract 2x from both sides. And we're going to have -4y is less than -2x plus 8. And then when I divide by -4, I would have to divide everything by -4. And I would have positive y. The sign here is going to switch because when I divide by a positive or a negative number, remember the sign switches. Negative 2 over negative 4 is 1/2 x. And then 8 divided by negative 4 is negative 2. And so I'm going to graph this equation. It starts at negative 2, which is right here. And the slope is up 1 and over 2. Up 1 over 2. We have another one here at up 1 over 2. Up 1 and over 2. And you can see that this doesn't have an equal sign underneath it, so it's just greater than this. We're going to have a dotted line here, which looks something like this. And it's y is greater than that, which means I'm going to shade everything above this line. So all of these points would make the equation true. Now I said that there was two ways to do this one, and there are. The other way to do this is to make an x and y chart and plug in zeros to find the intercepts. So for example, if x is 0, that means 2 times 0 is 0. This is not going to be there, which means negative 4 times y is 8. Well, negative 4 times negative 2 is 8, which means y must be negative 2. That means our y-intercept is right here at negative 2. Then if I let y be 0, that means this whole thing is going to be 4 times 0, which is 0. This is not going to be there, which means 2 times x equals 8. If I divide by 2, then x is 4. That means my x-intercept is 4 right here. So then I can go ahead and graph this line. Again, it would be a dotted line because it's just less than. But if we do it this way, we can't rely on the fact that if this is less than, that we're going to shade below it. Because we didn't shade below it. You can see we shaded above it. We would have to test a point. So I always like to test a point like a real easy point like 0, 0. And if I test a point 0, 0, that means this term is going to be 0 and this term is going to be 0, which means I'm going to have 0 minus 0. And is that less than 8? Well, 0 minus 0 is 0, and 0 is less than 8, which means this point works, which means everything else on this side of the graph is going to be going to make this equation true, and everything else on the other side, on this side, isn't going to be true. And so we have our solutions. So when we say solve this by graphing, what we're doing is coming up with all of the points that would make the equation a true equation. Let's try a different one. Again, we can do this two different ways. If I were to get the y by itself, I would add 10x to both sides, and I would have negative 5y is greater than 10x plus 20. If I divide by negative 5, again, I'm dividing by a negative number, so my sign is going to have to switch. I'm going to have y is greater than, this is negative 2x minus 4. And so it's going to start here at negative 4, and the slope is negative 2 over 1. Or I could go up 2 and left 1. And it's going to be all of these points in here. Again, it's going to be a dotted line because it is not equal to anything at that point, because it doesn't have a line underneath it. And its y is greater than that, which means everything over here on this side of the line is going to be shaded. And if I did it using the other method, if I made an x and y chart, if I let x be 0, then y is going to have to be negative 4. And if I let y be 0, then x would be negative 2. So we have the point here at 0, negative 4. Here's the point negative 2, 0. And I could graph that line that goes to those 2 points. And if I tested the point 0, 0 again, this would be 0, minus this would be 0. Is 0, 0 greater than 20? And we can see that it is. So it's a good thing I checked this, because this point, it isn't greater than 20. 0 to 0, 0 minus 0 is 0. 0 is not greater than 20, so I messed up here. This is not part of the solution set. So what I messed up on was none of these points over here work. And what I messed up on was, I may have said it, but I didn't do it as I was doing the problem. This sign here, because I divided by a negative, should be the opposite direction. It should look like this, which means y is less than that, which means all of the points that do work are going to be on this side of the line. All right, let's take a look at a different situation. Here we don't have an equation. We're going to have to write an equation. 3 burritos, I'm going to call the burritos x, and 2 tacos, I'll call the tacos y. So we have 3x plus 2y cost less than $12. So the price was less than $12. So we want to graph all of these possibilities here. And so I could do it one of two ways. I could set up an X and Y chart. I think this one I'm just going to do an X and Y chart. I'm going to plug in zeros. If X is 0, that means I didn't buy any of the burritos, just tacos. 2 times 6 is 12. That's going to be a y-intercept up here at 6. If I let y be 0, that means this is 0. 3 times 4 is 12. That means I could buy 4 burritos or less. And so it's going to look like this. If it costs less than $12, nothing on this line is going to work. Actually, 4 is over here, not negative 4. So this point is not there. So it's going to look something like this. It's going to be a dotted line that goes between these two lines, between these 2 points. And nothing on this line is going to actually work because that would be equal to $12. And it says it was less than $12. What will work is anything less than that. Now, we're going to learn later on that if we have a system, that we might have more than one equation. And here we will, because you can't buy negative burritos. The number of burritos that you buy has to be greater than 0 or equal to 0, which means X has to be greater than or equal to 0, which means here's where X is 0 right here. It's going to be greater than or equal to that, which means it's over here. And then same thing with the Y. You can't buy negative tacos. You buy 0 tacos or more, which means if here's where Y is 0, it's going to be above this line. And so we're looking for the region that's above this line, to the right of this line, and it's below this dotted line. And so what we're talking about is, let me use a different color here. What we're talking about is all of the points that are in this area, this triangle right here, would be possible things that we could have done with the burritos and tacos. Like, for example, we could have bought 2 tacos and 2 burritos, 1 taco and 3 burritos, 3 tacos and 1 burrito. So all of those would be possibilities here. And this would be the set that represents all of our solutions to this particular equation. That brings up some special situations. What if I have something like this? Y is less than 2. Well, here's where Y is equal to 2. Okay, so all of those points will work, but it could be less than or equal to 2, which means all of these points here would work because those are all the Y values that are less than 2. If I have another equation that looks something like this, X is greater than negative 3. Well, here's where X is equal to negative 3. Nothing on this line is going to work because it's just greater. But the X values that are greater than negative 3 are right over here. And so it could be all of these points here, or it could be all of these points down here that would satisfy this equation and make it true. So today we talked about graphing inequalities that are in slope-intercept form, standard form, and then some special cases where we just have Y is greater than or equal to something, or X is greater than or equal to something. And that's what our homework is going to look like, not only today, but also tomorrow. We will talk more about this in class. Good luck.